let me also open up the chat because I do want to invite people to ask questions as we actually go through the presentation. I will try to answer them while we're on the actual slide. Probably makes it a bit easier to have a discussion. So if there are any particular questions you have along the way, feel free to use the chat. Or if at the end of the session we have a couple of minutes left, I'm also happy to take those questions through audio. What I want to discuss today is the ever-evolving VMware infrastructure, and you may ask yourself what that is actually about. But it's actually fairly straightforward, right? The last couple of decades, actually, we've seen new features and new functionality being introduced in some shape or form within our infrastructure. We started out with regular virtual machines, but over the last couple of years, we've also seen things popping up, like, for instance, container technologies and Kubernetes. And of course, the VMware infrastructure needs to cater for that. That doesn't just apply to vSphere itself, but of course, it also applies to the layer that sits underneath. So that could potentially be the hardware layer, like, for instance, your Dell servers, your HP servers, et cetera, et cetera. And that is basically what I want to talk about today, because there's something interesting happening in the industry. And some of you may have seen that Frank Denneman, for instance, started writing a lot more and talking a lot more about AI and ML. And that's for a good reason, because we're starting to see a lot more customers actually exploring AI and ML. And that also means that from an infrastructural perspective, something new may be introduced in the near future, and something new may have already been introduced the past couple of years. So that's basically what I want to talk about today. I do have a brief disclaimer. You can talk about it on Twitter, you can talk about it on LinkedIn. That is not the problem, but I do want to make sure that people don't make any purchasing decisions based on some of the technology that I will be presenting today. Fairly straightforward. Some of the technology hasn't been committed yet, so there is no release date set. We don't even know if it's going to be released, so please don't make any purchasing decisions based on some of the projects that I will be discussing. Now, I think the key thing here to understand is when it comes to artificial intelligence and machine learning is that a lot of people are actually moving into this space because they're trying to get something out of it. Simply said, data is at the heart of every business transformation, basically meaning that if you want to move your business forward, you need to figure out what customers are looking for, what customers are interested in. And companies like, for instance, Amazon, and of course other companies as well have been doing that for ages, right? When you buy a book, or where you buy a pair of underwear or socks or whatever it ends up being, you always get these recommendations. Say 15 customers that bought this book were also interested in this particular book. So it's about upselling. Not just about upselling, of course, also being smarter about how for instance, you buy some of the resources you need, et cetera, et cetera. So there are a lot of details that go into the business transformation. But the key thing is the only way you can find out how you can be smarter about particular things is by looking at the data and analyzing the data. Now, of course, it's easy to say that you need to analyze the data, but where do you actually start, and how do you actually apply some of the things? And are these things actually things that are being used in day-to-day life? And one of the things that I always notice when we talk about AI and ML is that a lot of people say, okay, you know what? The company that I work for doesn't do anything with AI and ML. And typically, that is probably not true, right? There's a lot of companies already doing something with AI and ML. It's just that they're probably doing something more with machine learning than they are doing with artificial intelligence today. And I think these things are, different. A lot of people talk about AI and ML as if it's truly artificial intelligence, as if we have a machine that is doing stuff for you based on data that it's receiving. And that is actually not the case. It's primarily about pattern recognition, or something like language recognition, or maybe figuring out from a medical image what has happened to someone who's fallen, or whatever it ends up being, right? It's typically data is being analyzed, and a pattern is being recognized, and based on that, some type of conclusion is being presented. But it's being used by a lot of customers, and this poses a couple of challenges because, of course, you need to figure out not only how you can build the environment for it, but then also how you can use the environment for it. And something that we've seen over the past 4 to 5 years is that it seems to be extremely difficult to set up these environments for AI and ML projects. So if we look at the numbers, 47% of all of the AI and ML projects do not go from pilot to production. And there are a couple of really good reasons for it. The primary reason is that it's far too complex for a lot of customers to actually build these environments. It's mainly because there are different components that come into play. Yeah, I think that's a good question, Jane. Let me skip back to the previous slide. It actually says at the bottom what the source is. So it's from a Gartner report, Global AI Adoption.
Thank you. Sorry, I didn't see the small print. Thanks.
Yeah, no problem. We're all getting older, Jane. I know. I understand the issues. Yeah, so 47%, that is a significant number. And if you look at when you start deploying these types of workloads, there are a lot of different challenges that come into play. As already said, there's a lot of different components that form a solution like this. It's not just the VMware infrastructure. You also have things like, for instance, GPUs. Then, of course, a lot of these newer types of solutions actually leverage container technology. Those containers need to be scheduled with, for instance, something like Kubernetes. And then, of course, there are all of the different AI and ML technologies that come into play as well in terms of storing the data, analyzing the data, et cetera, et cetera. So it's a fairly difficult solution to actually start building. Now, that's only part of the problem, because then there are also other problems, of course, that come into play. Things like performance and scaling. In some cases, what we've seen with customers is that they had certain requirements from the time that it would take to analyze the data, because they simply would need to be able to make decisions within a relatively short amount of time. And that also imposes a lot of challenges, right? If you need to have the answer within, let's say, 2 or 3 minutes, but the analysis takes 4 hours, well, then the analysis, at least the outcome of the analysis at that point in time, may already be useless. And then, of course, there's the third aspect, which is scaling. How do you actually build these environments and make them scalable and repeatable so that you get a consistent result? And I think that is probably maybe even one of the most important things when it comes to these types of solutions. And last but not least, of course, when you start scaling them, it also needs to be manageable. And that is probably where the majority view will have the challenges, because what you'll end up seeing with a lot of these environments is that they are custom-built, siloed solutions. So, in the corner of a data center, you have 5 or 6 hosts sitting, which run a different operating system, which probably, are built from a different set of hardware. They typically contain GPUs, so they will need to be managed, not only potentially by a different set of people with a different skill set, but on top of that, also with a different tool set. So it becomes extremely complex. And that is, primarily the reason, those are primarily the reasons why these projects tend to fail. Now, this is also the reason why VMware and NVIDIA sat down and said, okay, what can we do about this particular problem? And VMware said, well, we've already seen this problem before. We've seen this exact same problem when we introduced HCI, vSAN. What a lot of customers were challenged with when they introduced vSAN in their environment with the very first version is that they had to go to a VM compatibility guide and then had to pick all the different components separately and form one single supported solution out of that. Now, of course, with vSAN, they only had to pick a disk controller, a capacity disks, and flash disks. That is only 3 components. But if you look at an AI platform, it's much more than those 3 components, because there's also a networking aspect that comes into play. Then, of course, there's the hypervisor that needs to be supported for all of those different hardware components. Then there's potentially the Kubernetes layers that sits on top of that. And then, of course, there's the NVIDIA tooling and, of course, the NVIDIA hardware as well that needs to be combined. So that is the reason that we started looking into creating this package, not just from a supportability perspective, from an NVIDIA standpoint, but, of course, also from a VMware perspective. And last but not least, we also need to make sure that these solutions actually perform well, because that is typically one of the key requirements when it comes to these types of solutions. So this is something that we've explored, and of course we came up with a solution, which is the AI enterprise solution from both NVIDIA and VMware, and we ensure that these solutions are actually supported end-to-end. Now, when you look at the solution itself, it doesn't just come with a server and a GPU and vSphere, but this actually contains support for the layers that sits on top of that as well. So, for instance, Tanzu is something that is supported on top of these environments, but of course there's the whole NVIDIA AI enterprise suite that you will need to leverage to start running these analysis that is also included by the platform itself. Now, when you look at the breakdown of this solution, it actually is, as I've already mentioned, very similar to a vSAN ready node. Of course, the big difference being that when you look at an AI or an ML platform, as I've already mentioned, there's more that is important for these environments than just disks or CPUs. And CPUs are actually not the most important things when it comes to these types of environments. It's things like GPUs, networking, which is much more important. Now you may wonder, why is this extremely complex, or why is this even, complex at all? And this is something that I asked myself as well. But the very first time I started looking into deploying a GPU in my environment, I found out fairly quickly that it's not as easy as it seems to be, because your server model that you are running needs to be capable of actually providing the power that the GPU requires. So just to give an example, we have 16 hosts within our lab in the US, and only 4 of those 16 hosts actually have the right power supply to be able to provide the amount of power that the GPU requires. So the GPU, in our particular case, the GPU that we want to run, not only is powered through the PCIe slot, but actually has an additional power connection as well that is hooked up through the power supply separately, simply because the amount of compute that is available on those cards. So there's a significant amount of power that is drawn by those systems. And that is one of the reasons we have created this pre-configured solution that is not only supported from an NVIDIA perspective, from a hardware point of view, but of course also supported from a vSphere point of view. On top of that, of course, when it comes to AI and ML, it's not just important to provide GPU resources, but on top of that, of course, you also need to be capable of delivering the data to those systems. And when it comes to data, the data that is being analyzed, in some cases, may be a relatively small amount of data, but what we've also started seeing with customers is that these data sets are starting to grow, and that is why it's becoming more and more important to have a significant amount of networking power available within these systems as well. And that is why NVIDIA and VMware included these DPUs. Now I have a separate section about DPUs, so we'll start explaining what a DPU exactly is and how you can benefit from it, not just from a networking standpoint, but potentially also from a security perspective, or maybe even from a storage point of view. But the key thing here, of course, as I've already mentioned, very similar to vSAN ready nodes. You pick a solution, or you pick a vendor, and then you pick the different components that you need, and you'll be able to run a solution fairly straightforward or easily. Now, of course, from a IT perspective, the key benefit here is not just the fact that it's a standardized, scalable solution, but in my opinion, is the cost savings that it will typically bring. Cost savings not only from the fact that it is a pre-bundled or a pre-packaged solution, but in my opinion, I think the cost savings will typically be on the operational side, on the configuration side of things, because all of these things have been pre-validated. The installation part and the configuration part is going to be much simpler than you will typically see with these environments. And for those who haven't actually looked into the solution itself, I would highly recommend watching some of the GTC, so the NVIDIA GTC sessions that are going on this week, that are introducing, a long list of new technologies, but one of the things that they're actually discussing is, in particular, is this stack as well, and some of the sessions, and I've actually watched some of the sessions, the previous GTC conference, and they actually go in depth over what all the different components are and what it would actually take end to end to configure it separately, and how it would actually work with a bundled solution. Now, when we are having these discussions with our customers, and I'm assuming that some of you may have had these discussions internally as well, one of the things that always comes up, and this especially is something that comes up in the high performance computing space, is what will it look like from a performance perspective? How will it scale? And will my performance actually be comparable to what my performance looks like from a bare metal standpoint? And of course, VMware and NVIDIA has done various benchmark studies. And what we've noticed is that from a scalability perspective, there is actually a linear scale. So when you add nodes to the cluster, of course, the number goes up as well. Now, from a performance standpoint, when you compare those numbers, they are actually relatively close. We're talking about single-digit performance differences. And in some cases, it could be that it doesn't. It means you're not meeting the requirements that for that particular process when it comes to the overall time that it should take to complete the analysis. But what we've seen in the majority of cases is that the operational benefit of actually running it virtualized typically exceeds the single-digit performance loss. Well, some of the benefits, of course, you're probably already, well, I'm pretty sure that everyone is familiar with them, right? Things like vMotion or DRS initial placements. Also, just cluster management in general when it comes to upgrading things like a vSphere or even all of the components in between. I think that is something that's very beneficial. But one of the things that I do want to point out is, although the slide does list vMotion, one of the things that you need to take into consideration is when you vMotion one of these virtual machines, is that there could be some downtime for the workload itself. So when you start running these workloads virtually, and you want to do some form of maintenance during the day, you need to take into account that when you move the workload around, there could be a downtime for that particular workload. Now, I know someone is going to ask the question, why would there be any downtime for the workload? And that has everything to do with the fact that if you move a virtual machine from one host to the other host, not only will we need to copy the memory resources for the virtual machine itself, but of course, we also need to make sure that the GPU resources are being copied. From a memory perspective, we as a hypervisor actually manage that end to end. But from a GPU perspective, at this particular point in time, we don't manage those memory resources. Those are just physical memory pages on the card itself. So we actually have to copy all of those pages from the GPU or from the source GPU to the destination GPU. So there could potentially be some downtime involved, which is the stun time, as most of you probably already know. Now, when it comes to the AI and ML projects, one of the challenges that we've been seeing with customers, and I've already briefly alluded to it, is that the time that it typically takes to run these analysis, to complete that particular phase, typically the most amount of time is being spent in terms that is being spent is typically data movement. That is something that we've seen. And of course, there's an analysis aspect of things as well. Now, you may ask yourself, why does that actually take a significant amount of time? Well, first of all, what we tend to see is that when customers actually go through this process, it's not like they have a single database. They typically have multiple sources for the data. That data typically needs to be copied out of the different databases into another data lake or whatever it ends up being. And there could be things like Databricks or Snowflake or any of the other solutions that are out there. Of course, there are many different solutions out there that you could use for these types of solutions. But of course, that means the data needs to be transported over the network in some shape or form. Now, we've all seen the introduction of 10 gig and 25 gigs and 40 gigs and 100 gigs over the past years. And we're starting to see that adoption, of course, in the data center as well. Majority of our customers actually run 10 gig networking today. And we're starting to see, a significant adoption of 25 and 40 gig and higher even as well. With Project Monterey, and this is our Smart NIC project, what we're actually aiming to do is we're aiming to provide an environment across the board that will allow you to be a bit more efficient when it comes to moving the data, right? What we've seen with a lot of customers is that they've created these siloed environments for their high performance computing. And what we're actually aiming to do with Project Monterey is we're trying to provide a platform that will allow you to actually roll it out across the data center. Now, as I've already mentioned, for AI ML projects, there's a lot of challenges, and moving data is one of those challenges. And we're trying to solve those problems with Project Monterey specifically. So we've had, of course, various discussions with our customers trying to figure out, okay, what are some of the problems that you're trying to solve when it comes to these AI and ML workloads? And specifically, when you are running these DPUs, these data processing units, or smart NICs, as they are called by the majority of the industry, what are some of the challenges that you're having? And one of the things, of course, that customers came back with is the management of these devices. And why is that a challenge? Well, if you look at the smart NIC itself, the smart NIC itself is not just a network interface card. it's actually more like a server. I have a diagram later on that will actually show you that. But that also means that from that point of view, the management itself is not like managing a NIC. It's not just about the firmware or about the driver, but there are many more components that come into play. You not only will need to be able to manage the firmware and the drivers itself, but you will also need to be able to monitor all of those different components and potentially the software that run on those different components. Because these smart NIC technologies, these DPU technologies, provide a lot of processing power. And as a result, they will also provide new opportunities within the data center. So within the data center, using smart NIC technology, in the future, you may even be able to start doing network or provide networking services on a completely different level. So you could potentially boost your infrastructure security leveraging smart NIC technology. And of course, on top of that, last but not least, as I already said, as data movement is extremely important in these processes, smart NICs could potentially help with that solution as well. And that is exactly where Project Monterey comes into play. Now, some of you may have already heard about Monterey when we introduced it at VMware or VMworld. And I think one of the most important things, which may not have been highlighted too well, in my opinion, is the security isolation that it brings. When we saw the demonstration at VMworld, when they were booting up ESXi on top of that hypervisor, I'm not sure, or on top of that smart NIC, I personally, for me personally, it wasn't obvious what they were planning on doing. But the key thing here is that they're actually moving critical components from the hypervisor itself onto the DPU, onto that smart NIC. And some of those components could be storage services, could be networking services, and it could even be infrastructure management services. So why is that important? Well, some of you may work, for instance, for a service provider. As you can imagine, as a service provider, it would be extremely important, first of all, to ensure that you have a secure environment, but secondly, also from a TCO or from a cost point of view, that you can actually resell all of the x86, so all of your regular CPU cycles, to your customers. If you can move down some of these different components that potentially consume a lot of CPU cycles onto the smart NIC, you now free up the CPU and you can sell those resources potentially to your customers. Now, of course, the same applies to our enterprise customers, or maybe not even enterprise customers, could be SMB customers as well, depending, of course, on what type of security requirements you have. Because we're actually providing the security isolation layer by introducing a new layer on the DPU, you potentially have a lower risk as well of, for instance, the different security breaches that we've seen. And we've all seen what has happened over the past probably 4 to 5 years with these ransomware attacks. And hopefully solutions like these will actually help preventing these attacks from occurring by actually isolating the different layers and making it more complex for hackers to actually breach your environment. Now, when we talk about Project Monterey, there are a whole bunch of use cases that typically come up. And I'm pretty sure that some of you may have your own use cases that you could potentially leverage the smart NIC technologies for. But there are 3 main use cases that VMware is looking into right now. Project Monterey is actually in early beta stage. And when it comes to the early beta stage, the primary focus is networking and performance. Of networking, performance, and security, I should rather say. So the focus is actually on moving these networking capabilities that are typically now provided by the hypervisor onto the smart NIC itself. First of all, offloading, of course, those CPU cycles to the smart NIC, but secondly, of course, and probably maybe even more important, providing that isolation layer. In the future, you can imagine, of course, that we can also leverage the same platform to start creating a disaggregated storage platform. Some of you may already be using vSAN. Some of you may have potentially already used something like HCI Mesh, where you can expose vSAN data stores to other parts of your data center. Well, you can imagine that in the future, you could potentially do the same thing, leveraging smart NIC technology and even expose, for instance, vSAN to a physical machine. So those are the different types of use cases that we are considering. And then last but not least, potentially if you're still running bare metal machines, we could potentially, leverage DPU technology as well to make it easier to manage those bare metal instances. But I do realize that the majority of customers, hopefully, or the majority of you hopefully are not leveraging or don't have too many physical machines running anymore. Now, if you look at these smart NICs, what do they actually look like and what do they actually entail? Well, of course, first of all, it's a NIC, it's a network interface card. So its primary goal is to ensure that you have connectivity between hosts, between services, between hypervisors. But if you start looking more closely at that network interface card, that smart NIC or DPU as it sometimes is referred to, one of the things that stands out is that it typically has a significant amount of processing power. And when I talk about significant amount of processing power, I actually have a slide later on that shows you the amount of transistors that is actually on one of those cards. And it is very surprising. But I don't want you to confuse these with regular x86 CPUs, because it's not a regular x86 CPUs. In the majority of cases, we're actually talking about an ARM CPU. We're talking about, from a gigahertz perspective, lower powered CPUs, but they typically will have a significant number of cores. So it is slightly different than what you normally see within a data center. The other thing, of course, is that there's a programmable aspect as well when it comes to these devices. So we as VMware, but of course other vendors as well, will be able to leverage the capabilities that are presented on this card and actually start virtualizing some of the functionality. So that could be, for instance, presenting local devices through NVMe over Ethernet across one of these smart NIC technologies to a physical host, or maybe to a different cluster, right? Some of those functionalities will also be available natively within these systems. Now, of course, ESXi will also be able to run on these platforms, and that is definitely something that we are aiming for. And that will also make it an interesting thing to manage. And some of you may have already seen that demo at VMworld that was done, I think, a year and a half ago. If you haven't seen it, I would recommend you to watch it, because you would actually see ESXi booting up on a smart NIC device and being managed by a vCenter server itself. Now, we're working closely with various partners. Of course, we're working closely with DPU or the smart NIC providers, and the smart NIC providers that we're working with from a design partner standpoint in this particular case are NVIDIA. And NVIDIA, of course, is the Mellanox solution that they acquired not too long ago. Of course, Intel, probably the market leader when it comes to CPUs at this point in time. Not the market leader when it comes to smart NICs, because I think NVIDIA is still ahead of them. And then there's a startup as well in this space that we are working closely with, which is Pensando. And these three form our technology partners from a DPU perspective. Now, of course, we're also working with the OEMs, because these DPUs or these smart NICs also need to be able to be inserted into a server. So we're working closely with Dell Technologies, HPE, and Lenovo to ensure that these systems will actually support these technologies. Now, we have these 6 partners listed here, and especially for the OEMs, the question that typically comes into play is, okay, what about Cisco? Or what about any of the other vendors out there? And of course, all of those other vendors are also vendors that we will ensure will work with these solutions. It's just that we're working closer with these partners to ensure that we're actually catering to the needs of their customers, but of our joint customers as well. And in the end, there's only a limited set of design partners that we can have. So these were the design partners that were selected for this particular smart NIC technology. Now, I've already mentioned it. If you look at the DPU technology, the big focus of DPU technology right now is offloading networking capabilities to the smart NIC itself to free up some of the resources. And I know that some of you have already deployed NSX. I know that some of you have experienced some of the challenges with that. And I also know some of our customers in Europe have seen, a significant amount of resources being consumed by NSX on their x86 CPUs, simply because of the amount of traffic that they were driving. And that may not be common for all customers, but it definitely will happen to some customers. And that is why, of course, the platform will allow you at some point in time to actually run these services natively on the smart NIC itself. As I said, the smart NIC technology or the DPU technology actually contains processing power. And what we're working towards right now is ensuring that with NSXT, you will be able to leverage that smart NIC technology and run your services, your networking services, your security service straight on that DPU, not just for ESXi, but potentially also for regular Windows machine, bare metal Windows machines, or Linux operating systems that run directly on top of that platform. Now, that may be a bit challenging to visualize, but you actually need to see this as two, well, they aren't separate computers because one computer actually sits inside of the other computer, but from a management perspective, they actually are two different entities. So that's the way you need to look at it. You have this bare metal operating system, and then potentially you have the vSphere platform sitting underneath, which actually caters for all of the different networking and security services, while the bare metal solution actually runs on top of the x86 platform that happens to be part of the same box. Now you may ask yourself, okay, how do we benefit from that? And I've already mentioned that we've had some partners and customers in Europe that saw that with their next generation firewall solutions, because they were running on top of their hypervisor, a significant amount of resources were actually consumed by that particular platform. And we actually have one customer that, because of the amount of resources that were being consumed, actually had to move away from a software firewall to a physical appliance again, because they were hitting like 60 or 70% resources being consumed on their platform. And if you look at these graphs, I think it instantly shows what the benefit is of a DPU compared to running your solution on top of your hypervisor immediately, right? I think probably the most shocking one is the one in the middle, where we talk about the CPU cores being consumed, depending, of course, on the amount of traffic that you drive. But when we did these tests, we tried to drive as much traffic as that we could. And as you can see in the middle graph, it actually shows that 12 cores were being leveraged when the firewall was actually running on top of the hypervisor, compared to, of course, no cores being consumed of the x86 platform when it's being offloaded to DPU. And that immediately shows you what the power is of a solution like this, right? Not only the cost reduction, but also the fact that you can run more workloads on top of that hypervisor at that particular point in time delivers a great benefit. And then we're not even talking about the security benefits when it comes to the isolation aspect of things. Now, the last thing that I briefly want to move over to before I move over to the next project that we are working on is the fact, of course, that we're looking into how we can expose storage capabilities, potentially something like vSAN across the network. Now, with DPUs, it becomes a bit easier because we now have an access point on which we could potentially run our software itself. So with vSAN, for instance, when you use something like HCI Mesh, we have a vSAN client. That vSAN client can be configured on a cluster which doesn't run vSAN itself. But you can imagine that in the future, when we load that client up on a SmartNIC or up on a DPU, even physical hosts, bare metal solutions would potentially be able to connect back to a vSAN cluster and leverage the vSAN resources, for instance, next to consuming, for instance, an NSX networking and security functionality on that same DPU. So those are the different things that we are exploring right now. Now, you may ask yourself, where is it going to stop? Well, we've hit Bluefield 3 right now. So Bluefield is the Mellanox NVIDIA technology that is out there when it comes to smart NICs. And I briefly wanted to show this because it gives you an idea of how fast this technology is developing from a smart NIC standpoint, right? If you look at Bluefield 2, 7 billion transistors, and you look at Bluefield 4, 64 billion transistors, you can imagine that the amount of processing power that is available for solutions that run on top of this platform is, it's much higher than they would ever have available within an x86 platform. The interesting part here as well is how the solution is created and what the platform looks like from a CPU perspective, right? It's much more about creating having the ability to instantiate parallel processes compared to what a normal CPU architecture would provide. So from that perspective, it is completely different and it opens up a lot of opportunities, but more importantly, it will enable you to start moving data around much faster. Now, when we start talking about data, of course, one of the things that always comes up is when we move data around, we're moving data around for a particular purpose. And that's where Project Capitola comes into play. Because typically when you move data around, it's going to hit memory at some point in time. Now, as you know, memory has always been a problem for VMware environments. One of the things that people or customers will always bring up is when it comes to resources, one of the big things that they're always challenged with is memory resources, right? There's hardly anyone that says that they typically, have sufficient memory but don't have sufficient CPU capacity. It's always the other way around. And the biggest challenge, of course, with memory typically is the cost involved with upgrading memory. So removing DIMMs from a server and introducing new DIMMs into the server, or maybe going from 8 gigs DIMMs to 16 or 64 or what it ends up being. The cost is typically significant, if it's even possible at all, because that is typically, of course, also a problem that customers hit. Now, with that, of course, what we're also starting to see is that there is a significant growth in terms of data that is being analyzed, and a requirement as well to start doing more of these analysis, as I've already said, to try to figure out, if people can be smarter in terms of how they are purchasing particular resources, or maybe how they are upselling, etc., etc. So they're trying to get more out of their data as well. That is something that we've been seeing happening across the industry. Now, when we look at these different trends, of course, one of the things we asked ourselves is how can we help providing a solution for customers that makes it not only easier to provide more memory capacity to virtual machines and to applications, but of course, make it a bit cheaper as well, because that is the biggest challenge that customers are facing right now. Of course, it's relatively simple to purchase new DIMMs, but if you look at the price of a server today, and I don't know if anyone has specced any server recently, and if you did, leave some comments in the chat. But I was actually speccing a server for a customer about 2 weeks ago, when we're looking into the price of DIMMs. And then if you look at the price of DIMMs and you look at a 16 gig configuration and you compare that to a 32 or a 64 gig DIMM, then you will see that the price, it doesn't scale linearly. So it is those prices go up extremely fast, and that also makes it fairly challenging. Now, of course, the other problem, of course, that we have is if you look at the growth from a CPU perspective, you compare that to the growth from a DIMM capacity perspective, there is also a discrepancy here. The growth from a CPU perspective has gone much, much faster than the growth of a DIMM perspective. So that is also introducing a lot of challenges for customers. And then the last thing that the customers are challenged with is that there are different types of memory these days. So we're not just talking about DRAM. We have DRAM that is attached through Fabric. Then, of course, we also have memory that comes in the form of flash capacity. So something like, for instance, Intel Optane. And then there are, of course, these different layers that come into play, right? Could be, for instance, presented through NVMe. That could be NVMe, which is locally. That could be NVMe, which is presented across the network, so over Ethernet on top of that. So that introduces a lot of problems. And one of the things, of course, that customers have asked us is, can we help with solving those problems? Can we abstract all of these different layers and present it into the virtual machine as a single memory layer, but then at the bottom end, actually be a bit smarter around how we consume these different layers? And that is exactly what we've started doing with a project Monterey, or sorry, Project Capitola itself. Now, before I show you Project Capitola, I want to point out one more thing when it comes to a memory problem, because this is something that a lot of people typically glance over or skip over. And that is the capacity of the DIMMs. I've already mentioned, the price of the DIMMs don't scale linearly when you look at, an 8 gig DIMM, or for instance, a 64 gig DIMM. But the other problem, of course, is the amount of DIMM slots that you have available within every single server. And you may ask yourself, why don't we simply increase the number of DIMM slots that we have available within these in these servers? Well, it's fairly straightforward. It's physics. the amount of connections that you can have to a single CPU is limited. The amount of pins that you have on a single CPU is limited. And on top of that, when it comes to the size, so the capacity of each particular DIMM, although we've seen them slowly growing over time, it is becoming harder and harder to scale that up. And the key reason for that, of course, is the fact that a DIMM is not just, it doesn't just consist these memory modules, but there's also a capacitor here that comes into play. And I think Lawrence also, points out something which is extremely important to understand. When you start introducing new DIMMs, DRAM in your environment, make sure to follow the guidelines of the manufacturer, especially when it comes to balancing, because it will have an impact not only on the speed of the DIMM itself, but could also potentially have a significant impact on NUMA. So that is something to definitely keep into consideration. Now, of course, when we look at these different types of solutions, the industry is already looking to solve these solutions, right? Now, some of you may have heard about CXL, Compute Express Link. And for those who haven't heard about it, it's a different way of actually presenting memory to the CPU. So how is this memory actually being presented? Well, CXL is not a new bus or anything like that, although it sounds like it, but it's actually a protocol that runs on top of PCIe. So basically what will allow you or enable you to do, or what the industry will enable you to do, is provide different type of memory modules over PCIe to your processor. Now, you may ask yourself what those look like. Well, of course, a couple of vendors are already starting to develop these solutions. This example actually shows a Samsung memory expander, and it's basically, it looks like an SSD. It will probably leverage, or it will leverage a PCIe slot, but it will then use the CXL protocol to connect the memory itself into that CPU. Now, of course, that may potentially provide some challenges for you, because when you have all of these different memory types, there could be, differences in speed, differences in latency, right? If you look at DRAM, we're talking about nanoseconds worth of latency typically. But when we talk about flash technology, or we talk about any technology presented over PCIe, we may be talking about, the upper end of nanoseconds, or potentially even milliseconds worth of latency. So that is definitely something that we need to be taking into consideration. And that is one of the goals that we have as VMware for Project Capitola specifically. So we are planning on providing a flexible memory management solution at a lower cost that you're running right now. Now, what does that look like? And I think that is something that is interesting, right? If you look at a typical virtual machine and you look at the logical view on the left side, a virtual machine typically has memory pages assigned to it. So you may have 16 gigabytes worth of memory assigned to that virtual machine, which is just exposed to the virtual machine as DRAM. So the virtual machine or the application can access that memory just like it's regular DRAM. Through Project Capitola, actually what we're aiming for is to provide the ability to specify that you would like to have a mix of DRAM as well as other types of memory presented to that particular virtual machine. But from a logical perspective, of course, the operating system is not going to know. So VMware is actually going to abstract those memory technologies, virtualize those memory technologies, and then present them as a single layer to your virtual machine, to your application, and your application will simply be able to consume it as if it's a single layer. But of course, smartness will be included on the lower end of that particular stack. Now, we're not just planning on doing memory tiering within that particular host, but we're also planning on providing a solution where you potentially be able to have some form of memory pooling. You can imagine that if you have a single cluster and one of your hosts was recently acquired and potentially has more memory than some of the other hosts in the cluster, that in the future, leveraging SmartNIC technology, because potentially, well, preferably you should have a low latency connection and high bandwidth connection to present memory to another host. But if you have that capability, then you could potentially not only serve up DRAM from one host to the other host, but potentially also other different types of memory solutions. That could be something like, for instance, persistent memory. So Intel Optane is a good example of that, but it could potentially also be a regular SSD. Now, of course, here it is important that latency is taken into consideration, because it could, of course, have an impact from a negative standpoint on performance. Now, of course, VMware wouldn't be VMware if we've already done some tests around this and what the impact would be if the hypervisor would manage a solution like this in a smart way. And what we've actually did is we used HammerdDB with SQL, and we tried to figure out what would the impact be if we would present different types of memory to a virtual machine, and VMware would be managing that particular memory layer, or it wouldn't be managing that memory layer. Now, in the first graph, what you actually see is that if you look at the graph itself, right, on the left side, what you will actually see is 32 gigs of DRAM is being presented to a virtual machine. So this is 32 gigs of DRAM that's directly presented to a virtual machine without any different type of memory being involved. Now, the second step, we have 16 gigs worth of DRAM that is presented to that virtual machine, and 16 gigs worth of PMEM presented to that virtual machine. And without any smartness, you can see that we instantly have a performance degradation of 23%, which is significant. And that actually, significantly degrades over time. Now, of course, we also are working on a smart tiering solution. And when that smart tiering solution actually comes into play, and this is, of course, a preliminary test, it doesn't actually say anything about what it will look like in the future, but it gives you an idea where we stand today when we leverage these same two types of technologies at the same ratio, but VMware actually decide which pages reside in DRAM and which pages reside on the slower memory tier. The performance degradation is far less, right? If you look at the first step, of course, there is a slight performance degradation, but the most important thing is the second, the third, and the fourth step, because the performance degradation is only 6, 7, and 8%, while the amount of physical DRAM being consumed is either 50% or much lower than that. So there's a significant cost drop from a TCO and a TCO perspective, but it doesn't come at a significant performance drop. So I think this is something that is extremely interesting that is being developed as it is right now. Now, just to be clear, as I've already mentioned, Project Monterey is something that is in beta right now. This is being tested by customers and partners. Project Capital is not something that is available. So this is, these are very preliminary tests. So it is something that I want to make sure that everyone is aware about. Now, of course, we're working with various industry partners, of course, the server vendors, and of course, the vendors that provide, memory technologies, whether that is someone like Micron that primarily focuses on flash and DRAM, or for instance, someone like Samsung. But it is something that we're actually actively working towards, not just from a memory standpoint, but of course also from a CXL, so the newer types of memory solutions that are out there. Now, the key takeaways before we wrap it up, and hopefully we'll have a minute left for questions if anyone have any questions left. Hopefully it's clear that something like Project Capitola, but potentially also in combination with Project Monterey, will allow you to start loading larger data sets into virtual machines at a hopefully lower cost. And these solutions hopefully will also make it easier to start not virtualizing these types of platforms, because I think that is something that has been missing, and especially in the HPC space, well, we've seen, especially the last decade or so, a lot of these environments are still physical environments, and we're hoping that with these two projects, we'll actually be able to provide a platform that will cater for these solutions and in a hopefully decently manageable fashion. And of course, last but not least, hopefully we'll also get rid of some of those purposely built silos that we've seen in the data centers, not just for VDI, but also for things like AI and ML, because that is something that we've also seen happening in the past 3-4 years, where customers are actually building these siloed environments, which typically are not used for 60-70% of the time, which only increases cost, but also makes manageability a lot more challenging. With that, we've reached the end of my session. Hopefully it was useful. If there are any questions left, feel to unmute yourself. For those who haven't seen it yet, for those who haven't heard it yet, we, Frank Denneman and Johan van Amersfoort and myself actually recently started a podcast. It's called the Unexplored Territory Podcast. It deals with topics like these. Could be forward-looking stuff, but it could also be things like that we've been using or consuming for the last couple of years, things like vSAN or VMware Cloud, etc., etc. Any questions?
Hi, Duncan. That was great. Thank you very much for that. One question around memory from me. It's fine looking at the hardware layer, but what are VMware doing about the increased memory usage of things like vCenter, VROPs? Those have all grown rapidly over the years.
Yeah.
Now with new VCLS, I mean, yes, it's only a small amount of memory, but each one takes a chunk of memory away from production VMs. And with VCLM, now to get the enhancements there, you need more supporting applications, again taking away more processor memory from the main production load. So how are you thinking about, or how is VMware thinking about reducing that complexity and usage?
Yeah, I think that is a fair comment, and it's actually one of the pieces of feedback that I've been giving for a long time. Right, we've all installed and configured vCenter many times, and we've all seen it growing from 4 gigs to 8 gigs to 16 gigs and larger, depending on the size of your environment. And it is something that is being taken serious by the team. We actually have developers that focus on optimizing the platform. Unfortunately, we've introduced some new parts of the stack. VCLS, for instance, one of those things that you've mentioned. For instance, for VCLS, I'm not 100% sure if I can share, but we're all friends here, so I may as well share it. But yeah, we realize that, for instance, powering on virtual machines may not be ideal. As you know, VMware is also working on a solution where we can run containers natively. So you can imagine that in the future, we'll have a solution that will run more natively on the platform itself, so that maybe as a container, maybe as a process. So we're actually working towards simplifying those things. One of the other things, of course, we're also planning on doing is trying to separate some of the components that are now part of vCenter and spread that across the environment in a more organic way. I think that is something that is probably long overdue. I think we've all expected it to happen, like have a more federated or microservices-based architecture for a solution like vCenter, but maybe also for VROps and some of the other components. But it wouldn't necessarily change the amount of capacity being consumed as a whole, but you may be able to spread that capacity consumption better across the cluster.
Across all hosts in the cluster, exactly, rather than on one host. Yeah. Okay.
Yeah, and that is some of those are challenges the customers are faced with, right? It's much easier to manage 10 4 gig instances than managing a single 40 gig instance.
Yeah, exactly.
And that's something that we've said to the team as well, and the team realizes that. The biggest challenge, of course, is you can imagine that, and I don't know if people internally have application developers that are going through an app modernization process, but breaking up an application in multiple different services and then managing, upgrading those services independently is not easy. And as you all know, vCenter has been around for ages, and it has grown relatively large as well over the past decade. And there's a lot of backwards compatibility when it comes that is required for our partners. So those processes unfortunately take a significant amount of time. But it is, I fully agree. It is a problem. And typically what I do after these events is I write down the comments and questions and feedback, and I'll feed it back to the engineering team once again and the product management team to ensure that it stays on their radar, because I do agree it is important.
Thank you very much. Much appreciated. Thank you.
Cool. So has anybody got any other questions? I mean, we're technically in the break now, so we've got about 15 minutes, I think, break time. So I don't know whether you've got to shoot off, Duncan, or whether you want to hang around. It's up to you. But if you've got more questions, otherwise, Duncan, that was really great. So thanks again for your support.
Yeah, no, I'll stick around if anyone has any questions or any other thing you want to talk about. Oh, before I forget, Simon mentioned the book. We're actually working on a new version. It's not going to be this thin because this was the previous vSAN book that we had, but we're actually creating a new version because the size didn't work for all customers, for all readers, especially the screenshots weren't always, readable according to some people. I guess we're all getting older. I have the same problem, so our eyesight is not what it used to be. So we're updating the book and creating a bigger format, so it's going to be a bit easier on the eyes, hopefully.
It's great that you're adjusting to your audience, Duncan. Well done.
Well, like I said, I have the same problem. It's I was looking at the feedback and then looking at the screenshot. I'm like, yeah, I know what it says, but it's barely readable. So
you may need to go for poster size.
Yeah, exactly. Yeah, have a book this big. Yeah, that's the interesting thing when you do self-publishing. Amazon actually the process works quite well. You simply pick a different format, you send the PDF, and you're done. That format actually, yeah, the process is really easy. You just change the size of your Word document, you send the PDF in, and they can print it in a different format. So that is quite nice.
Did not know they did that. That's great. Yeah, but it's like you say, you know what the screenshots say.
Yeah, that's the problem in general, right? That's the problem in general as well. When you're writing a book, you're writing everything down, and you know how it's supposed to work, so it all makes sense to you. But then someone else reads it, and he's like, "I'm not sure I actually understand what this says." So, okay.
Mind you, you are accessible, so they know where to find you.
Yeah, that's true. But I don't want to get 4,000 emails.
No. Sales of your book that good, huh? So that unexplored territory, when did you start that?
About half a year ago. We started about half a year ago. We've got about 12 episodes right now. We were supposed to record an episode yesterday, but we actually rescheduled it for next week. But yeah, the 13th episode should be out in a week and a half. From now, there are some really cool episodes on there. So we spoke with Kit Colbert, for instance, when he was just promoted to CTO. So he talks about his involvement in vMotion. There are a lot of rumors floating around that he invented vMotion, etc., etc. But so he talks about that on the podcast. And yeah, we had all sorts of people on the podcast. Sean Bass, it was a very interesting episode. Cody Hosterman to talk about vVols, which was very interesting. Of course, we had Cormac Hogan to talk about cloud native apps. And recently we had Jeffrey Custis from ITQ, which is a VMware partner, talking about VMware Cloud offerings and how a partner can actually help customers adopting VMware Cloud. I also thought that was very interesting. So yeah, we're all over the place trying to keep it as diverse as possible.
That's it, isn't it? It's getting the breadth of speakers and relevance and trying to keep up the frequency, I bet, quite challenging with the day jobs as well. Yeah, we actually initially planned to do we were thinking about doing a once a week, but the amount of time that actually takes to schedule these episodes, it's insane. Yeah.
And then, of course, you need to do the prep work. We did one on carbon black, for instance. I'm not a carbon black expert. So in order to be able to ask smart questions about carbon black, I need to spend 3-4 hours watching videos to write down questions, right? So yeah, that is also something I didn't take into consideration. So just an hour worth of content probably takes a day and a half, maybe 2 days to prepare and to edit, etc., etc.
Yeah.
It's also the editing. There's a lot of ums and ahs and other things you need to remove from a recording.
Well, you guys have got the professional setup these days with the mics and stuff. I've seen Johan when he's doing his, and he's got these great big microphones.
Yeah, that helps. Well, that's the one.
Editing's awful. I mean, I don't have to do too much of it, luckily, but I know when we did some of the videos for UK VMUG last year, I mean, I think even just to edit our 15-minute kind of intro,
yeah,
I must have heard my own voice about 1,000 times, and just it took me probably a day of chopping it about, trying to, like you say, trying to, particularly my, ums and ahs and ers and accidental swear words out of the
yeah, that drives, at some point in time, it drives you nuts. Like I had one person who had a nervous cough, just like every 10 seconds. So the thing is that I use Audacity to do the editing for the audio, and I could actually see, by looking at the pattern, if it was a cough or not. You just started recognizing the patterns. It's just like AI and ML, but then just, in my own head, I guess, you just start recognizing the patterns very fast. Same for ums and ahs. You start recognizing those patterns very fast, but they do look different for the different type of people. Depends on how heavy the voice is. It's a bit weird, but you get used to it.
I thought we were going to mention this. Sorry.
There's a new ML startup idea there, to go through. Make me sound better on podcasts.io. I'm sure that I'm registering.
There actually was one. Yeah,
there is one.
Yeah, and I looked at it. I think they already went bankrupt. I don't think it was a good business model, but I'm not sure it worked well either, to be honest.
But there are some interesting filters in Audacity that you can use that will get a lot of this out.
Is Reaper supposed to be a positive word for that? Get yourself a Reaper.fm for audio editing.
Yeah, we'll have a look.
I suppose it's culling it out. So, yeah.
Yeah, the challenge as well is with editing a podcast, and when it comes to ums and ahs, is that a lot of people, when they talk, they don't stop, or after or before they say or ah. It's part of their word or sentence. That makes it really difficult to remove it. Almost impossible, because it will just sound funny.
Yeah, it is an interesting point about how much prep it takes to make those things sound professional. I mean, and presumably it's the same thing with books, right? I mean, I remember when I did the PD book way back when. Right? I mean, I remember. Yeah, I mean, I'm a native English speaker, right? I mean, I get the edits of the book back from an American who basically completely changed what I'd written, but actually it's readable what he'd written. And if you look in the context of what I wrote, it makes sense to me. But if you get someone else to read it, they're like, you're rambling on, why have you put this word? That makes no sense. And,
that's the other problem we have with writing the book right now. I'm writing it with Cormac. I mean, he's Irish, so that's a problem to begin with. I'm Dutch. That doesn't help either.
Yeah, send the Dutchman.
So we have an American actually doing the proofreading right now.
Oh my God. Well, that's going to change the intonation of all of it, isn't it?
Yeah, exactly. For sure.
Yeah, I think it still haunts me to this day, the amount of times I had to, center and, all the American spellings of things. And I used to be really militant about always having the English spelling, and now I've I even find myself.
Ease up on it. Oh no, I can't do it. I can't ease up on it. And I'm always the one that's removing the comma before the and. Oh my Lord. They just overuse that so much. It's anyway.
Yeah, the first person I ever found was actually Alaric. If you ever had Alaric review something that you've written, he's really good at it. Actually, he's very good at it. Cool. So what sort of stuff are you working on at the moment, Duncan, in general?
Well, of course, vSAN, but yeah, this Project Capitola and Project Monterey is something that keeps popping up. So there's more and more customer interest for it. So we're starting to talk about it a lot more. But yeah, with vSAN, we're also working on new capabilities, or from an architectural perspective, we'll be introducing some changes in the future. That was also announced at VMworld, so I can freely talk about it. So that is also something that's starting to come up with customers right now. And yeah, as you know, the VMUG season is starting up again. So getting more and more VMUG requests. I had 4 VMUG requests from the US to do a keynote, but I just can't be bothered to fly to the US at this point in time. I mean, 10 hours in an airplane with a mask for a 45-minute session, it makes no sense.
No.
I mean, I'm happy to do it when there's 3 or 4 in the same week. Then I'm happy to do it, but not, just one. And one-off is not an option.
It doesn't justify it, does it? Either, you think of the green side of it as well with the flying to do that. It's unless you can combine it with visits, as you say, to relevant other meetings or other VMUGs.
Yeah, I mean, I've done South Africa as well, for instance, multiple times, but then they typically schedule 20 or 30 customer meetings alongside with it. So then it's okay.
Yeah.
But yeah, just flying out to Austin for one slot, or Portland, yeah, it's not doable.
Good. I think we've all become a bit more aware of it the past couple of years, haven't we?
Yeah, for sure. I did. I got half of my life back, so that
yeah, exactly.
Very pleasant, I can tell you that.
Yeah, you can tell with you guys as CTOA guys, especially just how much travel you used to do, and or the CTO guys, I should say. And it's nice to see you all enjoying time and appreciating family time again, and realizing there's a balance now that can be had.
Yeah, it's interesting because at the start of the pandemic, or at least for the first 6, 7, 8 months, people were talking about, the COVID kilos that they gained. I only lost weight because I wasn't traveling. I wasn't, eating as much outdoors. Yeah. Exactly, drinking.
It's yeah. Well, as did Joe. It scared the life out of all of us. But yeah, it's good. I think we get a balance back now. As I've got Barcelona next week, which will be my first one for a couple of years. But that again, everyone's very much flying in last minute on the Monday night for a full day meeting on the Tuesday, and then out again. Whereas it probably would have been 2 nights or so. Yeah. So everyone's just being a bit, staying away from home a lot less, I think. Just kids in the office.
Yeah, I haven't done as much travel in recent years. I used to do loads all over the place. I think probably the last 4 or 5 years I've just been in central London mainly for everything. But you can tell because all your statuses and everything expire, and you think, wow, do I really care? It's like bacon rolls were in the lounge, but really, I have some of my life back. Thank you.
Yeah, building up some tier points again. I think they're probably offering for you to be able to buy seats in the lounge now because they probably haven't got so many people in there.
Yeah, probably.
Right, I've got everybody who's frozen on my screen, so I'm going to drop and come back in again because I can't get this video to reset.
Cool. Yeah, we've got, I think the agenda's planned. We're going to kick off in about 15 minutes for
quarter past with James.
Yeah. So I'm going to go and grab a coffee. If anybody wanted to do the same, feel free. Otherwise, you can hang around and have a chat here.
Thanks again, Duncan. Appreciate it.
No problem.
Yeah, thanks very much. Cheers.